today's video lesson, we are going to look at systematic listing and the product rule for counting. If you would like to join in with any of the tasks I pop up on screen today, then just grab yourselves a pen and a piece of paper or a notebook. I will always advise that you have a go at a few questions for yourself to check that you are understanding what you're looking at in the video today. I'm going to jump right in, so if you need a moment to have a look at the task board, then pause the video and hit play when you're ready to make a start. Systematic listing is a logical and ordered way to list combinations effectively, so that we do not miss or duplicate any combinations. For example, if I have 6 counters and I only want to choose 2, there are lots of different pairs I can choose from. And I could start listing these pairs randomly. I could say the orange one and the purple one, the yellow one and the green one, the light blue one and the orange one. But after a while, I might lose track of where I'm at because I've picked them in a random order. We use systematic listing as a way to make sure we get all of the possible combinations without missing one out or without saying the same one twice. Have a look what I mean. If I pick first the darker blue with the orange, that's one possible pair. Sticking with the darker blue, I could also have the green. And if I continue on in the order of the counters, sticking with the darker blue, I could then pair that with the purple. Sticking with the darker blue, I could put it with the lighter blue. And sticking with the dark blue again, I could pair it with the yellow. So I've started and stuck with dark blue until I've paired it up in order with all the other counters it could be with. Then I know I'm done with dark blue and I can move on to the next colour. So let's say then next I move on to the orange counter. Now that's already been paired with dark blue in the first set, so I don't need to pair it again. So now I can pair the orange one with the green one, and then the orange one with the purple one, going in order again, the orange one with the light blue one, and sticking with orange, the orange one with the yellow one. Then I know I've paired orange with all the leftover colours. So that's dark blue and orange done with. I can now move on to green. We've already paired green with dark blue and with orange, but I need to still pair green with purple. I still need to pair green with light blue and green with yellow. And then that's green taken care of. So then I move to the purple, doing it in order in a logical, systematic way. I know now that I've already paired purple with dark blue, orange and green. And so as you can see, as we go through, we'll have fewer and fewer counters left to pair it with. So all I've got is purple left to go with light blue and purple with yellow. And that's purple done. So then we move to light blue. We've already done all the other pairings that came before it, so the only one left is light blue and yellow. Now the only time this will ever be different is if you've got a scenario where you compare dark blue with itself, for example. Now I've only got each counter once, so if I definitely want 2 counters, I can't have 2 dark blues because I've only got 1 dark blue. But if you had a scenario, and we'll come across one soon, if you had a scenario where you could have a counter paired with itself, then you'd have an extra set to work with. Let's have a look at some example pairs together. Here are 4 tiles, each with a letter on. 2 tiles will be chosen. List the possible combinations. So I'm going to do the exact same thing as we've just done with counters. I'm going to start with A, because that makes sense, start at the beginning. And I compare A with B, I compare A with C, and I compare A with D. And then that's A done, and I won't be going back to it. So now I go to B. Well, I've already paired A with B in the first instance, so I don't need to pair B with A. That's going to get me the same 2 tiles. But what I can pair is B with C and B with D. And then that's B done. Then I've got C. I don't need to go back and pair it with A, and I don't need to go back and pair it with B. But I can pair C with D, and then there's nothing left for me to pair D with. We've done them all. Now you can see this structure I've written it in. You don't have to write it like this, but sometimes it can just help you to see that you've got them all. Because I can see I've got A with everything, and then I can see I've got B with everything left over, and then I can see I've got C with everything left over after that. Here's a very similar question for you, just to practice this skill. there are 5 tiles, each with a numeral on. So you've just got 2, 3, 5, 7 and 9. Those are just 5 numerals I picked at random. 2 tiles will be chosen. List the possible 2-digit numbers that can be made. So you can make any 2-digit numbers here. Now, depending on how you look at this question, you might notice a slight difference, but I'll leave you to have a go at it first, and then we'll come back and we'll discuss how this might be slightly different. Pause the video now and hit play when you're ready to see the solution. Okie dokie. So if we approach this question exactly like I did with the previous one, I'm going to use some space at the top for this one. I could have gone with 23, 25, 27, 29, and then told myself that's the 2 done with. And then I could go in and say 35, 37, 39, and say that's the 3 done with. Then I could go in and say 57 and 59, and that's the 5 done with. And then lastly, 79. And if you did that, that's brilliant. That's exactly mirroring the method I showed you before. However, you might have noticed something a little bit different about this question. This question asks us for any possible 2-digit numbers that can be made. Well, if I took the 2 and the 3, for example, we know I can make 23, but I could switch those round and make it 32, and that's technically another 2-digit number. So I could put 32 just there and swap them around. Whereas with this first example, we have just assumed that if I take the tiles AB and BA, that's just the same 2 tiles. However, this question about listing numbers is slightly different because of the context. We can put them the other way around and create a different number. So when we went into the next column and we were looking at the 3, we said we could have 35, but we didn't consider that we could also have 53, because we'd ruled out that we were finished with the 3. We'd done the 3, we'd moved on. But likewise, if we go back another one, we could have also had 52. Filling in these gaps, just putting the digits the other way. And by the time we got to looking at what the 5 could be with, we went 57 and then 59. And then we said, well, we can have 7 and 9, but we didn't consider that we could have 7 and 5, 7 and 3, 7 and 2, just the other way around. And then lastly, in my previous example, when I'd done C, because there was nothing else left to pair D with, I was done. And we could have assumed the same here. Once I was done with the 7, there'd be nothing left for 9. But actually, we could have paired 9 with the 2, the 3, the 5, or the 7. So actually there were 20 different combinations for this one, which you might have spotted and you might not. If you got that first part right where you did the first half, then that's great. As I said, that's mirroring the method I showed you. But some of you might have spotted just an extra bit with that one, and if you did, well done. So that was systematic listing, finding a structured way to go through and list all the possible combinations. We then have this thing called product rule for counting, and that's about how many outcomes there are. You don't necessarily have to list them all, but you do have to be able to say how many there are. So in the example with my A, B, C, D, there were 6 different combinations. We had A and B, A and C, A and D, then B and C, B and D, and C and D. Total 6 combinations. And as we saw with the example that we've now got on screen, there were 20 combinations. We just listed them all. But if the question doesn't ask you to list them, there is a much quicker way, and we call it the product rule for counting, to go from how many options there are to how many combinations there are. Let's break it down a bit. When you first go to choose a tile, because it's not necessary if we're going to pick tiles that we'll always pick them in order. If I had to put them in a bag and put my hand in, think a bit like a game of Scrabble, and take a tile out without looking, doesn't mean I'm always going to get 2. I could get the 7. I could get the 5. I could get any of them. The point is, when we first choose a tile, there are 5 to choose from. And let's say I did pick the 7. Okay, got it. When I come to choose the second tile, I've got 4 left to choose from. Product means times. 4 times 5 tells me that if I'm going to pick 2 counters from here, there will be 20 combinations that we can pick from. And that makes sense. We listed those 20 combinations on the slide before. Now, this changes if I change the number of tiles that I pick. Let's say I've still got my 5 tiles, but I'm going to choose 3 of them this time. So instead of it just being 2 and 3 for my first number or potential number, it's going to be 235. And I can also have 237. And I can also have 239. And the list is going to go on and on and on and on and on. That's going to take me longer to list all those combinations, and let's look at why. The first time I go to pick a number, there's going to be 5 tiles to choose from. Let's say this time it was the 3. The second time I go to choose a tile, there's 4 for me to choose from. Let's say that was the 9. And then the third time, because this time I'm saying I can pick 3 digits, the third time there's 3 tiles for me to choose from. Let's say that was the 2. So for me to pick any 3-digit number from these 5 tiles, 5 times 4 is 20, times another 3 is 60. That would have been 60 possible combinations that I would have to write down, which obviously I don't want to spend my time doing, and I can't imagine you would too. So sometimes you'll get a product rule question where they just ask you how many combinations there are, rather than listing all the combinations out. On to some example pairs for this one then. A lock has a 4-digit code. The digits can be from 0 to 9. How many combinations are there? Now with a question like this, you need to consider whether each time you pick one, whether it reduces the number you've got overall. So when we were picking tiles from a bag, every time I took one, it meant there was one less in the bag. That's how I ended up doing 5, but then times 4, and then times 3. With a question like this, the first digit in my lock can be anything from 0 to 9, which is 10 different digits. If you think you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's actually 10 different digits because you've got 1 to 9 and then you've also got the digit 0. So on my first slot on my lock, I've got 10 possibilities. When I then look at the second number on my lock, I've still got 10 digits. There's not now only 9 digits because it's just a lock. It's not like I've taken something out of the bag and taken it away. So digit number 2, there's still 10 choices. And digit number 3, there's still 10 choices because it can still be anything 0 to 9. And digit number 4, there are still 10 choices. So the product rule is a very simple method, but you do have to interpret the question and the scenario you've got in front of you in context as to whether you need to reduce these numbers each time or not. And in this case, it's not. 10 times 10 times 10 times 10 is 10,000. So any 4-digit combination lock will have 10,000 possible outcomes. Here's another one. An ice cream shop lets you pick 3 scoops to go in a cone. They have the following flavours: vanilla, chocolate, strawberry and mint. How many combinations are there? So thinking about this in the same way. Pause the video so you have time to have a go at this one and then hit play when you're ready. Okay, so an ice cream shop lets you pick 3 scoops to go in the cone. Now there's nothing to suggest that they have to be 3 different scoops. If they wanted it to be 3 different scoops, they would put the word different in the question. So if you wanted 3 scoops of vanilla, you can have 3 scoops of vanilla. And I'm sure if you went to an ice cream shop, they would let you do that. And if you want 2 chocolate and 1 mint, they'll let you do that as well. So the way we're going to work that out is we think about our first scoop. Our first scoop, we've got 4 possible flavours. We can have vanilla, chocolate, strawberry and mint. In our second scoop, we've still got 4 choices. It doesn't matter what I picked for the first one. If I pick vanilla, for example, I could have vanilla again, or I could have one of the other 3. That's still 4 to choose from. And same again. In our third scoop, there are still 4 flavours to choose from. 4 times 4 times 4 is 64 combinations. So there are 64 different ways that you can pick a 3-scoop ice cream. Let's have a go at some multiple choice questions now. I will pop a 10-second timer on the screen, but if timers don't work for you, don't worry. You can ignore it and pause the video and then hit play when you're ready to see the answer. Here is a menu in a cafe. You can choose from sandwiches, cheese, ham, veggie and tuna. A snack, there's cake or crisps. And drinks, you can have tea, coffee or hot chocolate. How many combinations are there if you want to choose a sandwich, snack and drink? So one thing from each section. Here are your options. Well, there were 4 sandwiches, 2 snacks and 3 drinks. 4 times 2 times 3 is 24. So if you said C, that's correct. Let's just do one more. Here is a timetable in a gym. On Monday, there are Pilates, spin and Zumba activities. On a Tuesday, weights and running. And on Wednesday, yoga, circuits, hoops, aerobics and sauna. How many combinations are there if you want to choose one activity for each of the 3 days? Here are your options. Well, there are 3 choices on a Monday, 2 choices on a Tuesday, and 5 choices on a Wednesday. 3 times 2 times 5 is 30. So that would be D. On to a bit of independent practice. Here are 3 questions for you to have a go at. Pause the video so you've got time to work them out and hit play when you're ready to see the answers. And here are your answers. Do go through and check those. If there's anything you're unsure about, feel free to go back and watch the examples again. Sometimes it can just help to see them once more. And if you need specific guidance on a particular question, then please let us know down in the comments. We do aim to answer all questions and comments related to the content of the video. All that's left to be said is a big well done for taking part in today's video lesson. Just a reminder that every little extra bit you do will help you greatly towards your outcomes at GCSE, so do keep working hard. Give the video a thumbs up if you enjoyed it and subscribe for more video lessons, or so that you can reach out to us if you need help at any point along your journey preparing for your exams. If you also like short form content, we post revision quizzes and tips over on TikTok and Instagram. I'm Charlotte, thank you for watching this video.